Hello everyone, this is Liang Junwu, and today I will talk about homework 6, question 1 and question 2. Okay, let's see the question 1. Given fxy is this form, and the first question is to calculate a, and we know fxy is a valid joint density function. That means double integral fxy dx dy is equal to 1. That means we can get this equation and calculate this equation. We can get a is equal to 1 over 4. And second question is ask about xy are correlated. So we from the definition of correlated, we know exy if exy is equal to ex minus ey, that means they are uncorrelated. So we can calculate exy and ex and ey. So we first calculate exy, that is equal to double integral xy minus this is fxy. So this equation, then we can get exy is equal to 1 over 9, and ex is equal to double integral x minus fxy. That means this thing, and we calculate this equation. We can get ex is equal to 0. So obviously exy is not equal to ex minus ey. We don't even calculate ey, so we can conclude that xy are not uncorrelated. Then the third part ask about xy are independent. So we must equal to fxy and fx and fy. So we can get fxy as given from the first part. So we just calculate fx and fy. Fx is integral dy, integral fx dy, that is equal to 1 over 2, and fy is equal to integral fxy dx, that is also equal to 1 over 2. So we can get fxy is equal to 1 over 3 minus 1 plus xy, and fx minus fy is equal to 1 over 4. So these two parts is not equal. So we can conclude fx and y are not independent. Then the fourth part, we have to find the joint density function of x square and y square, and we can let z is equal to x square and w is equal to y square. Then we can get this two equation x is related to xy, and xy has two roots. That is this has 4 roots, and this 4 part, and we can also get jxy is equal to maxtrol 2 and 2 maxtrol. That is this 4 part, and we calculate it jxy is equal to 4x minus y. So from this 2 part we can get we know this equation is from definition of PDF, that is FCW is equal to fxy, the 4 roots into it, and the absolute of jxy, that is x is equal this 4 part also give it in, and we can calculate this 4 equation, and we get FCW is equal to 1 over 4 square root z minus square root w. And the last part is prove or disprove x square and y square are independent. That means we have to calculate FC and FW. FC is equal to integral from 0 to 1 FCW dW. So we can calculate it as 1 over 2 minus square root z, and the FW is equal to integral FCW dc. That is equal to 1 over 2 minus square root w. So we can get this two part FCW is not equal to is equal to FZ minus FW. These two parts minus together and is equal to this part. So we can get C and W are independent. That is x square and y square are independent. Okay, that is question 1. So let's look question 2. Question 2 is given fxy and xy are equal are this in equation. So find A first part. As we know, fxy is a valid joint density, that is double integral fxy dx dy is equal to 1. That is this part, this equation. So we just calculate this equation. This part is so when we calculate this part is very difficult. We can let x is equal to sin theta, and just this part is equal to cosine theta, and dx we can get the cosine theta minus d theta, and the integral limit of integral is changed also. Then we calculate it. That is a is equal to 1 over pi, and the second part is find EW. This 7 things, and firstly we calculate EX. We know EX is equal to integral double integral dx dy. That is that is x minus fxy. So we get this equation, and we calculate it. When we get this equation, we know this part is a order function. So and the limit of integral is symmetry. So we can get this part integral this part is equal to 0. So we can get EX is equal to 0. Then we calculate we calculate EX to Y. So we must calculate EFX to Y, and so we need to calculate fx. Then fx is equal this equation, that is integral fx dy is equal to this part, and fx to y is equal to fxy over fy. That is a is equal to 1 over pi and minus this part. So we can get fx to y is equal to this part. Then we calculate x to y is equal to integral x minus fx to y dx. So we can get this equation, and this part is also a odd function, so we can get ex to y is equal to 0. And these two parts just rewrite y to capital Y. These two parts is equal, so just rewrite the or small y to capital Y. So ex to y is equal to 0. Similarly, we can get ey to x is 0, and y to x is capital X is also equal to 0. Then the last part we will calculate exy. Exy is equal to integral double integral xy minus fxy, that is a. So we get this equation, and we calculate this part. This part is equal to 0, so we don't need to calculate later. Exy is just equal to 0. Then we can get the C part. C part is asked about xy's uncorrelated. That is exy is equal to ex minus ey, so xy are uncorrelated. That's it. Thank you.